Hello everyone, my name is Prithvika K, student of Sri Venkateshwara College of Engineering, Bengaluru. I'm currently pursuing my engineering degree under CSE AI stream. My USN is 1VE23CA036. Course title Oops with Java. Course code BCS306A. And today's topic is about inheritance and its types. Introduction. Java is high-level language, class-based, object-oriented programming language developed by Sun Microsystems and first released in 1995, designed to have a minimum implementation dependency. Java is known for its write once, run anywhere capability, meaning that compiled Java code can run on any platform such as which supports Java without needing recompilation. Java's syntax is similar to C++, but it has fewer low level facilities, making Java the better choice for building portable, secure, and scalable applications. Java programs run on Java Virtual Machine called JVM and Abstract Computing Machine that allows Java applications to run on various platforms. Java is widely used in developing web applications, mobile applications, especially on Android mobiles, desktop applications, and large systems. It supports core concepts of object oriented programming such as inheritance, encapsulation, polymerization, and even abstraction, making it versatile for developers. Java vast standard library includes packages like Java Standard Edition like Java SE and Java Enterprise Edition like Java EE, provides built-in support for essential functions and networking capabilities. The language also secures with features that prevents common disadvantages like pointer issues, and due to its efficiency and extensive community support, Java has remained one of the most popular programming languages worldwide. Its scalability, reliability, and versatility makes it ideal for wide range of programming tasks, for small projects to large scale enterprise systems. Inheritance. Inheritance is a core concept in object oriented programming that allows a new class, which is also called a subclass or a child class, to inherit attributes and methods from an existing class, which is also known as superclass or parent class. This helps in creating a hierarchy structure where the subclasses can extend or override the functionality of the parent class, promoting code reuse and reducing redundancy. Inheritance enables subclasses to share common behavior from the parent class while also adding their own unique features. In Java, inheritance is achieved using parent class um, and the extend keyword, where the child class can inherit properties and behavior from a single parent class. And also Java doesn't support any multiple inheritance directly. When a subclass inherits from a superclass, which is called as a parent class, it gains access to the public and protected members, but the private members remains unaccessible. Inheritance also supports polymerization, where a subclass can be treated as an instance of a parent class, allowing more flexible and intensible code. Overriding is an aspect of inheritance that lets a subclass provide a specific implementation for a method already defined in the parent class. Inheritance promotes a modular approach to coding, and changes in the superclass can automatically reflect in the subclass. However, it must be used carefully as improper use can lead to tightly coupled code which can be harder to remain debug. In types of inheritance, we have single level, multiple, multi level, hierarchical, and hybrid inheritance. We have the flow diagrams for different types of inheritance, where we have single level inheritance, hierarchical inheritance, multi level, multiple, and hybrid inheritance. how the classes are derived from one single class, or even the classes derived from multiple classes to form a structure. Single level inheritance. In single level inheritance, it is a type of inheritance where a subclass inherits directly from a single superclass or single parent class. In this setup, only one level of inheritance exists, forming a simple relationship between the parent class and the child class. The child class gains the access to all the accessible properties and methods of the parent class, allowing the code reuse and reducing redundancy. Single level inheritance is a straightforward and helps in creating a clear and manageable code. This type of inheritance is commonly used when a class simply needs to extend or slightly modify the behavior of another existing class. And we also have a small code for which it acts as an example. And we also have a block diagram how the subclass and the superclass inherits their properties. Multi-level inheritance. Multi-level inheritance is a type of inheritance in which a class inherits from another class, which in turn is derived from a third class, forming a chain of inheritance. In this structure, each subsequent subclass inherits properties and behaviors from all the ancestors' classes, creating a multi-tiered hierarchy. For example, if a class C inherits from class B, the class B inherits from class A. Then class C inherits characteristics from both B and A. This type of inheritance enables code reuse across multi levels and also allows deeper extension of baser classes. While multi-level inheritance provides flexibility, it also requires careful design to manage dependencies and maintain code clarity. We also have a small code and a block diagram where we can see that C is the main class, or it is also called a superclass, and it is and the B subclass or B child class can inherit the properties from C, and A is a subclass which can inherit both the properties from B and C, as it is the last class. Multiple inheritance. Multiple inheritance is a form of inheritance in which a class can inherit attributes and methods from more than one parent class. It also allows subclasses to combine features from multiple classes, promoting flexibility and reusability. However, multi inheritance can lead to complexity and potential conflicts, such as diamond problem, where it raises a issue when two parent classes have methods of same name. To avoid these complications, Java does not support any multi inheritance directly through classes, although it can be achieved using interfaces in languages to support it directly. Multiple inheritance is a powerful but requires careful design to manage dependencies efficiently. We have a small example and syntax block diagram where we have three different main classes, and it is inherited to one single child class. Hybrid inheritance. Hybrid inheritance is a combination of two or more types of inheritance, such as single, multiple, and multi level inheritance used together in a single structure. This approach allows classes to inherit properties and behaviors from multiple sources in flexible hierarchical setup. In Java, hybrid inheritance can be achieved using classes and interfaces, since Java does not support multiple inheritance directly with classes. For example, a class might inherit from a parent class while also implementing several interfaces, allowing it to incorporate various functionalities. Although hybrid inheritance can increase code reusability, it also should be used carefully and managed to avoid complexity and maintain code readability. We have a small block diagram. We can see that the single level inheritance and multiple inheritance is combined to give the hybrid inheritance. Hierarchical inheritance. Hierarchical inheritance is a type of inheritance in which multiple subclasses inherit from single superclass. The structure allows each subclass to access the properties and the methods of shared parent class, promoting code reusability across various and different types of subclasses. For instance, if a class B and C inherit from class A, they gain access to attributes and behaviors, allowing shared functionality with their unique extensions. Hierarchical inheritance is a beneficial when multiple classes need similar foundational behaviors but also require their own specific features. This type of inheritance provides a clear structure but can lead to dependencies on the parent class. So, it is essential to design the parent class thoughtfully. We have a block diagram which we can have a clear look into that. We have base class and two derived class, which means two different means it can have only one base class and it can have more than two subclasses. Let's see the conclusion. Inheritance is a foundational concept in object oriented programming that enables classes to derive properties and behaviors from other classes, promoting code reusability, modularity, and efficient organization. Throughout the various types of inheritance, single, multiple, multi-level, hierarchical, and hybrid uh, inheritance, the programmers can create flexible and layered structure tailored to different design needs. Each type of inheritance offers unique advantages. Single inheritance is an example or a simple direct method. Multiple inheritance allows a combining multiple sources with some complexity. Multi-level inheritance build upon successive layers. Hierarchical inheritance provides a shared foundation for multiple subclasses, while hybrid inheritance combines several approaches, often using interfaces in languages like Java. However, while inheritance allows for powerful design patterns, it also comes with potential pitfalls such as increased dependency and complexity, which requires careful planning and implementation. Understanding when and how it is used each type of inheritance ensures a balance between flexibility and simplicity. Ultimately, inheritance allows for cleaner and more organized and maintainable code, especially in large products where structure is crucial. Inheritance thoughtfully is essential for creating scalable, extensible, and efficient applications.